All right. Hey everyone, I'm George. I'm from Docker. I'm a software engineer in the Docker Desktop platform team, and basically we are building stuff around Docker Desktop and some parts of Docker Desktop. And one of the most interesting specifics of building a client application app is that you cannot just fix something quickly. You still need to deliver the fix to your users. And because of this fact, we are, I would say, extremely dedicated to testing. And we always try to find new ways how to improve our testing experience. And basically, this talk is one about our latest experiments in that area. So just to give you a bit of a context, Docker Desktop is huge. It's a big monorepo. And Docker Desktop is covered by 6,000 E2E tests. They're split in 138 groups. So what do we mean by groups here? First, it's a list of groups, like AKA areas of what's being tested, like Compose, Kubernetes, or networking, or I don't know, performance. And then that number of groups is multiplied by the number of operating systems we support, which is Mac, Windows, and Linux, some distributives, and also multiplied by the number of architectures we support, which is AMD64 and ARM64. So for each group, it takes approximately 16 minutes to finish the test suite. And in addition to these numbers, there are 6 teams working on the same project, in the same repo in parallel. So that makes things well, interesting. And with so many developers and so many tests, it's inevitable that we deal with flakiness or failing tests from time to time. And I mean, it's just part of the game. And it's important to say here that I think I misclicked something. All right, yeah. Now I have 2 mics. All right. So it's important to say that tests are meant to fail. That's the whole point. The real challenge is to be able to fix them quickly. So in our case, the ability to fix, is it okay? Yeah, all right. So in our case, the ability to fix failures quickly is really important, because if something that is flaky makes it to the main branch, we treat that as an incident, because the rest of the developers are now kind of blocked. They cannot merge anything because of this flakiness in the main. And we need to fix it immediately. And one of the many responsibilities of my team is to refine this process of fixing to make it easy, basically to make this debugging journey fast and simple. So today I'll walk you through one of our approaches here. All right, so what's the problem? Imagine that this is Docker Desktop, and this is how I test it. So we have this E2E test binary, or E2E test service, I'm going to call it in both ways, that just sends basically some HTTP requests to Docker Desktop. And in the end of the test suite run, we have this log generated by our E2E test service or binary, and this pile of logs generated by Docker Desktop. So I'm going to give you a bit more context about what these files are and what's the difference between them, what's the context of those files. But now let's try to debug something with this schema. So first, and I think it's quite obvious, you need to try to read the test job output, the red file. And if that doesn't help, you can try to read Docker Desktop logs or Docker Desktop diagnostics. Or if that doesn't help, you can try to look at the test code or at the source code. Or if all these things didn't help, then you can try to run the test locally, which is unfortunately not always possible, because if the test is failing only on Windows ARM and you have Mac ARM, you cannot reproduce it locally. So we actually took a look at this thing, and we thought it seemed like a bit too much reading here. So we decided to ask others. We decided to ask other developers, what do they think about this flow, this process that we have? And I mean, perhaps something is indeed far from being perfect here. So here are the results. I'm going to quote this lines from the document that we created in the end. So Docker desktop logs are difficult to read. They are scattered across many different files. So this quote is about that pile of files above Docker desktop that I showed before. So in fact, that's something that we call diagnostics. Is there a video? Okay. So that's something that we call diagnostics. So it's a zip archive that we generate in the end of the test run. And it's just a mix of logs written by different internal components of Docker desktop, as well as some C-like commands outputs just to get the state of the machine at the moment when the test failure happened, like ps or vmstat, all that jazz. So yeah, as you can see, it's a lot. There was a bunch of files that you need to go over, find the one that has the info that might help you to find what was the problem. And I mean, yeah, it's not so easy. Next point is, since backend components are constantly communicating with each other via IPC, logs can also be intermixed since everything is concurrent. So this part is about the file that we generate in the end of our E2 test run. So that one single file is in fact more of a mix of logs from other different parts of the whole process. So indeed, it has the E2 test logs, all the like names of the tests, the results, but also we put these snippets of some parts of the backend log just to make it more like in place, make it easier to access what was happening on the backend by that moment. But the result, I mean, the intention was good, but the result is just here we have this kubectl output at the top for some reason, and then we have some snippet from Kubernetes module of the testing framework, and then we have some other part of the backend log. And I mean, I don't know, I think it's a mess, and it's quite easy to read. And yeah, valid point here as well. Next, next is more of a conclusion of everything that was discovered before. So in the end, to debug something with our current approach, you need to build something like a mental model of what happened by just reading all these files, and then in the end you can try to figure out what was happening. But it involves a lot of reading, and that's a lot of time, which doesn't fit with our requirement being able to fix something fast. So the results of the survey kind of confirmed our theory that something was wrong, and it was actually getting worse because, I mean, the project is getting bigger, we have more features, and it's just natural. So we decided to try to tackle the problem. And here's our idea. So the idea is, what if we replace all this reading and keeping in mind with just looking at the problem, looking at what was happening. So let's try to visualize the entire test suite run to make it just like you click, and then you see the problem. So essentially, we can collect all the data from all the sources that we are interested in, and we can map them on a visual timeline of the entire test run. So that was the idea. And I mean, what we really need to know when you are thinking about the test suite is start and stop of each test. Also, all the interactions of your E2E test with your product. Also, in our case, everything that's happening inside of Docker desktop, because a complex thing, it has a lot of stuff inside, a lot of components, their own APIs, and we would like to see those interactions as well. All the errors that we, raise, or if there was a test assertion that failed, we would like to highlight that as well. All the logs that we write, because I mean, they are really crucial, and metrics, especially for performance tests. And actually, if you look at this list, and if you look at these words, I think you guys can guess what we decided to try here. So, yeah, we decided to try open telemetry for the desktop application for testing process. Now, raise your hands who knows what is open telemetry. Okay, cool. Then I'm going to just quickly give some basics about it. Something is on with this clicker, yeah. So OpenTelemetry is just a big open source framework, aka tooling, aka like standard that basically standardizes the way how you should collect your observability data, which is metrics, logs, and traces. So in case if you want to bring some observability to a project, you don't need to like reinvent the wheel here. You just need to go to their website and find the right library for your programming language and just enable them, and it works. So it's a great tool, and let's try to map this tool to our schema that we have. So I have to say that we need to start from this. So we added our OTel collector to our schema, but in fact, that's because by the time when we started working on this project, Docker Desktop had already been sending some traces and some metrics in a very limited amount. That was added as a test for one component, and it wasn't something that we like imagined to see. It was just a one component of it sending this traces, but this really helped us a lot because the infrastructure for OpenTelemetry was already there and it was configured, and we just started using it. For us, it was a quick start because I mean we are obviously not pros in OpenTelemetry, and especially in the infrastructure, so we just started using what we had. So now about our steps, we want to add traces, logs, and metrics to our E2 test binary, and we want to add logs to Docker Desktop. Docker, covers of these things. All right, but for now, let's go back to what we have right now. And the first thing, let's kick off with the visualization tool. So having this approach, having the tool to see the results of our work will help us to debug the further steps and to validate our further steps. So since we already had been sending some data, that means that it's somewhere out there. So let's try to find that data. Effectively, we want to be able to say like, hey, I want to see all the telemetry data collected from this particular test run. And the solution is quite trivial. We just need to add something like an ID to every single piece of data that we sent during the test suite. So that ID should be unique for this test run. So that's what we did. We added this OTel attribute. Yeah, so we added this same OTel attribute to every span that we create. So span is the minimal like element of trace. So trace is a list of spans chained together. And we added the same OTel attribute just to be able to filter everything we sent. And we started generating this link to Grafana Explorer. That's the tool we use to view the trace. And we started posting that link in the end of the test suite log. This is how it looks like, just like telemetry data here, Grafana. And if you click on it, it will bring you here, which is just a preset attribute in the search field with this value. And yeah, you just see everything you sent right here in this table. All right. Now we can update our schema and say that we added Grafana tempo here. Next, let's move on to adding traces now. And the first thing that comes to your mind when you're covering E2 test suite is I want to know when this test started and when it finished. And that's about every test. So let's just wrap our tests. And it's actually quite easy to achieve here. We just need to start a span at the very beginning of the test. In our case, this is just a real test from Docker Desktop that requests versions info from the backend. And yeah, let's just wrap this one. We use Ginkgo as a test framework. So we create this wrapper around this it function that Ginkgo uses. And we basically just start the span in the beginning and defer to sending, and that's it. Yeah, this code is somewhat simplified, but it's very close to the reality. And now, if you look at the, oh, come on. Yeah, and now if we look at the table that we have in the Grafana Explorer, amongst the existing backend spans and traces, we can also see our test traces. All right. But if you're familiar with Ginkgo or any other modern testing framework, you know that in addition to the test itself, we also can declare things like before each, after each, before cleanup, before all, after all, and it would be nice to have them as well. So those are just yet another Ginkgo functions that we can wrap in the same manner, and that's what we did. And now if we look at the table, we started seeing those as well, like here, for example. But still, this is far from what we imagined to see, and we need to bring some hierarchy to our traces. So what do we mean by hierarchy here? If you're familiar with tracing, you know that one of its main benefits is that you can see the affiliation between the events, the hierarchy of what was happening. So you can basically see what was happening, for how long it was happening, when it was happening, and what distinct sub-events were happening while it was happening. So we need to apply that idea to our visualization on the left here. And that's basically something like this. This is how we all imagine our test suite. So we have the first test block, which has the before each and after the test itself, and then after each, and the same thing for the second test. So in order to achieve this kind of visualization in the trace, we need to get a bit of the theory on how tracing works in general. So every time we create a span, which is, as I said, the minimal entity of trace, there are two ways how to position your span. So it's either a child of another parental span, or it's a root span, which means that there is no parent for this span. So in case of a Go library that we use here, you can do that with context. So there are two contexts here. The first one is in the arguments, that one, and then there's another one with the returning values. So the first one is used when you want to say that, okay, this new span should be a child span of this span that I just passed, the context of that span. And the second context is going to be used in the future when you want to create another span that's going to be child for this one. So as you might have guessed, yeah, that's how it works. And there's another code to just explain. Oops. There's another code to explain how this works. So here I have grandparent span that has a context background in the first argument, which means that there's no parent. And then I passed its context to the parent span creation, which means that parent is a child of the grandparent, which makes sense. And then the same thing for the child. And that's how it works. Is that clear? All right, great. So now after we applied, and if we look at our table right now, the one that we have here, we have traces, but if we click on any trace here, there's going to be only one span inside because we don't have any parents at the moment. So let's call this table an orphanage, for example. Now, yeah, after we applied this context magic to our Ginkgo wrappers code, this orphanage is going to be converted into this, which is our test suite. The entire test suite, separated by like test case by test case. We can clearly see the timing of each test case. We can open it. We can see what was happening inside. And I think it looks great. We can easily find the tests we're interested in. And yeah, so now we can update our schema again and officially say that we added traces to the E2 test binary. Now, next step, errors. We run tests, we raise errors, we have assertions that they tend to fail, and that's kind of the way the things are. And what we want to do here, we want to mark the entire test case span in some red or something as failed if one of the assertions failed. And also we would like to, if we return some error from somewhere, for example, from some API, we would like to highlight that as well. So how can we achieve this? It's also very easy for the test assertions. Ginkgo allows you to declare this, fail handler functions. So it's just the code that's going to be invoked once there is an assertion that failed in your code. So what we do here is we just get the current recording span, and we add the information to it. And yeah, the result is going to be something like this. Yeah. We can see this red exclamation mark inside of the test case trace, which signalizes that, hey, take a look here. All right, context propagation. This is actually the most interesting part. So let's take a look at our code again and take a closer look to this line. So here we are making an API call to Docker desktop backend. We say, hey, give me versions info, please. So, oh, come on, what's happening? All right. But if we look at our trace, there's no sign that we actually made some external call or something. We just have this it, which is where the test case was happening, basically, and that's it. And that's because here's what's happening right now. So we have tests in the backend side, and on the test, we create a span, the one that I showed you a few slides before. We request versions. Then on the backend side, we handle that request. We collect all the versions info, and then we send a response. After that, we get the response from the test. We do some assertions to do the actual test. And in the end, in the very end, we send the span that we just created. Yeah. Now, this is not really what we want to do. Since we want to start seeing some traces being sent from the backend, we should also send the span from the backend. Oh, this clicker is... Can I just use my keyboard? All right. So we want to start the span in the backend as well, like this. And it's also, as anything else with open telemetry, easy to enable. You just need to find the middleware for your web server and just turn it on. In this case, we use Echo, and we just enabled it. We added it to our router, and the result is here. If we look at our orphanage, now we can see our backend traces there. But that's not really what we want to have. We want to see them here, because this call happened right here. So how can we do that? This is where context propagation kicks in. Essentially, we need our e2e test backend binary to say to the backend, like, hey backend, in case if you're going to be creating some, here's the info about the currently recording span that I have here. So your spans should be child spans of my span. And in Go, that's doable with the context. So if this context is enriched with the telemetry info, and that's our case, because we basically create this context, you just pass the context to your HTTP do function. And yeah, that's it. You need to also add this transport wrapper to your client, which is also another open source thing, just to extract the telemetry info from the context and send it as a header, if I recall correctly. I think it's a header. So yeah, this is the result. Now we can see our backend displayed in our trace. So here it's not really visible, but it has a different color because it is essentially another service. And that way it is highlighted that it's actually another service. And yeah, now we can update our schema again and add context here. Right. Next. This is actually the funniest part. I mean, context propagation, because if you don't have proper context propagation in your project, you're going to have add it to your code base. And what I mean here is if you have this function called chain, like 20 functions in the end with the HTTP do client do function call that should have a context. And when you're writing it, it's happening quite often that you're writing some code and then you need to pass the context and you're like, oh, come on, I don't need context. I don't really need the context here. Let's just pass background context. But there will be this moment where you actually need to bring that context there. So you will lose your mind adding to your code base. And that's actually what happened to us, me and my colleague. We spent days adding context to our code. We started making memes about context. So yeah, and there's this phrase, the best moment to start investing in stocks is today. So the best moment to start passing context is today. And yeah, that was hilarious. And actually, another hilarious thing, if you look at my contribution graph, you can guess where I was adding context. So this is the day where I merged that big PR. And because of this, like the difference of the contributions, the whole other year is now faded, and I cannot change it actually. So yeah. So invest in your context, please. Yeah, please pass it everywhere. All right, next, logs. Obviously, we write logs, and it would be nice to see them on our trace as well. And basically, we just need to wrap our logger and make him send those logs to the telemetry collector. Yeah, historically, we've been using logos. Please do not blame us for that. We are switching to slog right now. But yeah, how to wrap a logger. Oh, come on. Yeah, I got it. The problem is that the stable Go logging collector is not released yet. So it's currently in beta. It's not in alpha. This screenshot is a bit old. So it's in beta. And obviously, when we were working on this, it was in alpha and we didn't want to use it. So we started seeking for something else, and we found this solution, which is just a workaround for loggers. So it basically just sends your logs as events attached to your span. And that was kind of right for us. And we just enabled that thing. All you need to do is just another middleware or hook or so-called, yeah, here is hook. Basically just another function that's going to be involved when you are writing log. And yeah, just enable it in your logger and add context to the place where you write log. Yeah, looks a bit ugly, I agree, but you can do like log equals log with context and then use the logger. Yeah, and again, a lot of context. Don't even ask me how much time we spend on this. That's again a lot. So yeah, but it kind of works. And we also wrapped this Ginkgo bycall, so it's just another fancy way to print something provided by Ginkgo. And we did the same thing as we did with any other setup nodes from Ginkgo. We just get the current span at the event and send it. And this is how it looks like. We can click on the span, and there's this expandable section called events, and you can see all the logs there. So now we can add logs to our schema. Now I'm going to show you some more real screenshots. Am I? Yeah. So yeah, here's another one. This is from the real test run. We can see how many backend calls we have here. We even have attempts here on the left. And the way how we achieved that is it's another talk, I assume, because at some point we were talking to the creator of Ginkgo, trying to come up with a way how to make it work. Yeah, another screenshot here. I think I should move. Yeah. Yeah, and this actually is my favorite one. So Grafana Explorer allows you to highlight those spans that are longer than some time, for example. So if you're having problems in your test suite, meaning that it's running too long, you can just easily highlight those that are, in this case, longer than 20 seconds. Yeah, another screenshot here. This is just some log that was written deep inside Docker Desktop's backend. Okay, next we wrote a page in Notion about how to use it, since this telemetry-based debugging approach is still relatively new to the team. So we explained how to use it, how to run the whole stack locally with just compose up, and how to add more coverage with it. Because even though we covered some parts of Docker Desktop with the telemetry, it's impossible for a couple of people to cover the entire Docker Desktop because it's gigantic. So we covered some major parts that are good for the showcase. And that was kind of our mistake. We should have covered more. But yeah, that's what we did. And we also left this demo PRs explaining how to expand telemetry coverage. Basically, those are just our PRs when we were adding coverage. And next, about the results. We did demo to every team, explaining how to work with it. And after 2 months, the results are that developers like it. They use it, not all of them, unfortunately, but we're kind of working right now on our advertisement project on this thing. We're trying to encourage the developers to use it more and to expand its coverage, because that was, as I said, that was one of our mistakes, that we covered just a few parts. So yeah, another thing we noticed is that developers most often use it when they need to debug something quickly, and that was the original intention. Actually, we want to decrease the time you need to spend to debug something. So yeah, we're happy. And also, we were surprised by this part. They actually started sending out PRs, improving all this thing, and it happened in the very beginning of, like, right after we launched it. And we received a couple of improvements from the developers, and I mean, that's always great. And another thing, yeah, the coverage, as I said, is still far from being perfect, but we are actually, we were speaking about this today with the colleagues. Now, what's next? Obviously, more coverage. We want to, in the perfect future, we want to cover the entire Docker desktop with traces and logs and tricks. Yeah, we need to add metrics. We didn't come up with anything how to add them properly. So we will probably get there as well. The most obvious thing is performance tests. So yeah, also some basic visual improvements, since I mean it's never perfect, so there's always room for improvements here. And the last two things are for me, they're the most major. Docker Desktop is an Electron app, so we have this front-end part that is unfortunately not covered at all. We have a lot of tests there as well, so we'll probably get there. And the last thing, in addition to this HTTP calls that we make from our testing framework to the backend, we also do a lot of just the CLI commands, like Docker PS or like Docker start. And would be nice to pass context through those as well, because I mean, they're just part of the testing process. And we were thinking about how to do that. The most obvious thing that first comes to mind is just environment variables. But for that, we would need to alter those CLI modules as well. So yeah, we'll see. And some takeaways now. Just because something is familiar and something that you are used to, it doesn't mean that it should stay the same. You should always try to look at your current setup from a different angle. Like you were in the team, if there's some process, imagine that you were new to the team and try to come up with something, try to find some improvements. Next, turned out that telemetry can be used in many weird ways and unexpected ways. So yeah, try to cover your microwave machine with telemetry, probably, maybe that will work. But yeah, we kind of misused telemetry here. It wasn't like its original official use case. So it worked and it works. So yeah, try. And yeah, in general, keep experimenting. yeah, keep experimenting, try to find some ways to express your imagination in your work. So yeah, it always has some benefits, And yeah, the last thing, context propagation is an investment. Please do that. It will save you a lot of time and mental health in the future. Highly recommend it. And thank you. That's it.